in this page, in this PPT, we find producing machine language. We can find in the former class we have studied in lecture 9. In lecture 9, we find producing machine language is the procedure in the assembler language. We find this is two sections. One is simple cases. Simple cases have included arithmetic and logic instructions. We find arithmetic and logic instructions is very important in instruction set. We find all necessary information have contained in the instruction. So the instruction can do anything. We find what about branches and jumps? Branches and jumps require a relative address. Once past due instructions are replaced by real ones, we know by how many instructions to branch, so this is no problem. So you can find the branch and the jumps in every programming language. In C, in C++, and Java, we can find the branch and the jumps. The representation of branch and jumps are different, but branch and jumps key is existing. They are existing. For the reference problem, we can find the branch instructions can refer to labels that are forward in the program. The solution is make two passes over the program. So you can find the LE, LR, L1, L2 is two labels. Two labels in the program. This is the solution. Okay, we can find the pass 1 and the pass 2. Pass 1 extends pass 2 instructions encountered. Remember position of label. Take out comments, empty lines, error checking. Pass 2 has included use label positions to generate relative addresses, output the object file, a collection of instructions in binary code. This is the overview. Okay, this is two problems. One is what about jumps to external labels? We can find requiring knowing a final address, forward or not, can't generate machine instruction without knowing the position of instructions in memory. So the external labels can retrieved by the jumps. The problem 2 is what about references to data? LA gets broken up into LUI and ADDI. This will require the full 32-bit address of the data. This can't be determined yet, so we create two tables. Simple table. We can find a simple table. List of items that may be used by other files. Each file has its own symbol table. What are labels? Data. Labels is function calling. Data is anything in the .data section. Variables may be accessed across files. Keeping track of the labels fixes the forward reference problem. So you can find keeping track is the important procedure. Relocation table. We can find the list of items. This file will meet the address of data. The address is the memory address. What are they? They are external label. Jump to JAR or JALR. He has internal and external. So all external have included internal and external, including library files. Any piece of data, such as anything referenced in the data section, he is the Z, the relocation table. Okay, we can find the object file format has included six formats. One is object file header, 2 is text segment, 3 is data segment, relocation table, symbol table, and debugging information. Debugging information, we can't care, we don't care, because the debugging information is for debug. Debug procedure is very important, but it is difficult. It is necessary in the system debug, but in the program developing procedure, the debug is not necessary. Okay, we can find the assembler. We can find the assembler every time or sometimes. He has 2 sections. One is input, 2 is output. Input is assembler language code. For example, SOO.S for RISC-V. Output is object code. So assembler, the output of assembler is object code. Object code is true assembler. It has information tables. So we can find the object file is the output of assembler. Reads and use directives, replaces pass-through instructions, produces machine language. Is the use of object file. You can find the pass-through instruction is the immediately procedure. He is immediately procedure, or we can find we call the result of immediately procedure. Pass-through instruction is not real code. His use is for understanding. We can understand pass-through instruction easily. So pass-through instruction. You can find the pass-through instruction in programming language, in computer organization. We can find the pass-through instruction is not real language.
It looks like algorithm.
You can write pass-through instruction by English, by Chinese, by your language. Okay, we can find after assembler, we can find the linker and the loader, and for example, we can find the linker, the lib.o is the input of linker. The input is object code files, information tables, for example, SOO.o, lib.o for RISC-V. The output is executable code. The executable code, you can find one format is .out. OUT is being represented. They can output. But .exe is another format. You can find executable is very important words for the output. .exe is the executable file. You can find double click this file. You can find the running open. Combine several object files into a single executable. You can find the procedure is linking. So you can find in this flowchart, we can find this is the flowchart. You can find the linker and loader is the last steps in the flowchart. We like flow chart, and the flow chart can represent the procedure of all of the procedure. So we like draw the flow chart by Photoshop Visual. You can find Visual is a very useful software. I tell my students, for example, use this software can draw the flow chart, every flow chart, every file. So the Visual is very useful language from Microsoft. So you can find some useful software from Microsoft can archive our minds. Yeah. Okay, you can find enables separate compilation of files. Change to one file do not require recompilation of whole program. Old name is link editor from editing the links in jump and the link instructions. You can learn. Okay, you can find the left section has two object files. In the middle, you can find the linker. In the right section, you can find the output is a.out. So you can find this is relocated data. Or you can find text segment from each .o file and put them together. Take data segment from each .o file, put them together, and concatenate this onto n of text segments. Resolve references, we can find go through relocation table, handle each entry. So you can find, for example, fill in all absolute addresses. Absolute addresses is the real addresses. So you can find the addresses is main memory address. Okay, this is there are three types of addresses. You can find one is PC relative addressing. This is never relocate. Number two is external function reference. You can find the external function reference always relocate. Static data reference always relocate. You can find in RISC-V often uses AURPC is static data reference rather than LUI, so that a big block of stuff can be further relocated as long as it is fixed relative to the PC. So you can find in the static data reference, we often use the AUIPC and ADDI. Okay, this is the absolute addresses in RISC-V. The problem is which instructions need relocation editing. We can find the jump and the link is the important section in format. We can find the loads and the stores to variables in static area relative to global pointer. We can find the load and store. L and S can archive the files. Linker assumes the first word of the first text segment is at the number for RISC-V, RV32. More later, when we started virtual machine is actually in disk. His section, virtual machine, this section is the position of virtual machine is in the disk, not in main memory.
Yeah.
Main memory is more than disk.
Yeah.
The size of disk is big and big. So we can use some some sites in the disk, we can use this section to virtual machine. So we can find you can find the virtual is the term. Linker knows length of each text and data segment, ordering of text and data segments. Links calculates we can find the absolute address of each label to be jumped to and each piece of data being referenced. Okay, let's see. Okay, to resolve the references, we can find the three sections. One is search for reference. Two is if not found, search library files. Three is once absolute address is determined, fill in the machine code properly. The output of linker is executable file containing text and data. So you can find the linker, the output linker is executable file. Executable file is important output result. So you can find in the flowchart, we can find the loader. The loader is the last step in the flowchart. We can find according to the loader, we can find the output is memory. The memory is represented main memory. So we can find in the computer organization, we can call memory as main memory. We can call disk as secondary memory. So you can find memory. We can divide every or several kinds of memory. Okay, you can find the loader. Loader is the last step. We can find the loader as include input and output. Input is executable code. Output is program is run. So the loader is necessary.
Just load the program.
Yeah, it's run and run. Executable files are stored on disk. You can find when one is run, loader's job is to load it into memory and start it running. So you can find the memory is main memory. So you can find execute files according to loader. We can find the execute files is running in the memory and started running. In reality, loader is the operating system. So you can find this is another course. You can find you have studied operating system here in this semester.
In this semester.
Yeah. You can find the loading is one of the OS tasks. Operating system had including several management. So the operating system is very important. We can find in the loader, we can find the reads executable file header to determine size of text and data segments. It can create new address space for program large enough to hold text and data segments along with a stack segment. So you can find the stack is necessary structure in computer organization. The stack is very useful. Copies instructions and the data for executable file into the new address space. You can find the loader is useful. The 4 and the 5 and the 6, you can find the copies arguments passed to the program onto the stack. The number 5 is initializes machine registers. Most registers clear, but stack pointer assign address of first free stack location. So the first free stack location is the start of the programming. The number 6 jumps to start up routing that copies programs arguments from stack to registers and sets to the PC. So you can find that the PC is programming counter. Its main routing returns uprootting terminates program with the exist system call. So the call is the signal. Okay, we can find this is a call example. In C programming language, you can find in the former class we discussed C programming. We can find this is the C programming. The main function has printf and return two sentences. You can find the printf is the call. So you can find the compiled hello.c to hello.s. In the last section, you can find this is the assembler language. The last section, this is the assembler language. This is the description. So you can find the description is very important. A good coder had writing more and more descriptions in this coding file.
Comments.
This is useful to understand.
Yeah.
So after
anyone can understand, read these comments.
Yeah. So after some weeks, we can't remember this.
It's very helpful.
This use. Yeah. So you can find you can trust the description more than our minds.
Yeah.
Assembler hello.s. You can find that this is linked hello.o. You can find in this format. You can find that this is the object file. You don't remember the format. You understand enough. This is the hello.o. You can find ADDI is the important procedure. Okay, you can find the compiler, assembler, linker, loader. This is the summary for these four sections. Compiler converts a single HLL file into a single assembler file. So you can find from .c to .s. Assembler removes pass-through instructions. So you can find pass-through instructions. The remove of pass-through instructions according to assembler converts what it can to machine language and creates a checklist for linker. Here is a relocation table. So you can find the .s can become .o. Assembler resolves addresses by making two passes. Linker compiles several object files and resolves absolute addresses. So you can find .o can become .out. Linker enables separate computation and use of libraries. Loader loads executable into memory and begins execution. This is the summary of lecture 9. So you can find in the beginning of lecture 9, you can find compile, assembler, linker, and loader. From this flowchart, you can find this is the procedure. So you can find this is the four important sections. Yeah. Let's continue. Let's continue. Look at these PPTs. Some PPTs are studied, so we can look quickly. So you can find this is started. This is procedure calling. You can find the 6 steps. One is place parameters in registers. 2 is transfer control to procedure. 3 is acquire storage for procedure. 4 is perform procedures operations. 5 is place result in register for core. The last step is return to place of core. So you can find the core is very important for function. The function is important for programming language. So we can find the C programming language is suitable for computer organization. Assembler language is more suitable for computer organization. So we like, as a teacher, we like to tell our students C programming language and assembler language is useful. But in the later, we find Java and Python is more useful. So we hope our students learn C and assembler language. But in the future, Java, Python is useful for your works. In the future, our students can work as by Java, by C++, C#, and Python. Yeah, my postgraduates have studied Python as language tools. His research field is computer vision. Like this camera, we have researched algorithms, improved algorithms in some devices, and can perform more and more effect. Is our researching fields. So you can find in the website, in the Google, in the Baidu, our famous companies had more and more algorithm engineers in this famous company. So you can find China is become powerful and tough. So in every field.
What of company name?
Yeah.
Company name?
Company.
Yeah.
I don't know.
I told that where you research the algorithm engineering company.
I have a company. I have a company. I'm a tutor. I'm a tutor. So in our college, in our computer and communication college, we like postgraduates. Yeah, I'm a tutor. I am a tutor for postgraduates. So you can find it in the website. I have a CD or discussion in our website in CSUST. So you can discuss, you can research some your interesting research content in the future. In this semester and in your 4 years, you can find you can achieve the bachelor is your mind. Okay, this is this is local data on the stack. We can find in the lecture 8. We can find this is the procedure of local data allocated. can find this is producing an object model. Assembler translates program into machine language, provides information for building a complete program from the pieces. They have three sections. One is header, two is text segment. This is the linking object model. We can find the produce and executable image. We can find the three steps. One is merge segments. Two is resolve label. Yeah, three is patch location. You can learn. Loading a program, they have six steps. Dynamic linking has three features. So you can find the starting Java applications. You can find the Java virtual version is the necessary tools. He can interpret bytecodes. You can find the Java library routines as machine language. You can find the class file is necessary for Java. Okay. This is the symbol of Intel. You can find 808 is the first CPU from Intel. So you can find 8086, 8087, 80286 as continued. You can find every symbol of CPU has continued and continued. This is the basic x86 registers. So we can implement complex instruction set, makes implementation difficult. Hardware translates instructions to simpler micro operations. Micro operations is necessary and important for operating system. Okay, this is the all content code. Okay, let's have the study lecture 10. Okay, we can find the lecture 10. His name is combinational logic. Combinational logic. We can find this is the former in lecture 9. We can find the after core. We can find the hardware design is the discuss content. You can find in this page, in this image, we can find that this is the low level as computer science. We can find the machine interpretation, architecture implementation. In this section, we can find that we can learn, but we can't design. Who is the designer? The Intel, the AMD, the famous company. We can't design. We can learn. We can learn in some contexts. We can find. So the problem is why study hardware design? Because we can't design hardware, but we are necessary study. Be able to answer the question, how does a computer work? We need some digital systems knowledge to build our own processor, but this is difficult. This is difficult task. We can understand how code is actually executed on a computer. This is easy. Understand the capabilities and the limitations of HW in general and the processors in particular. What processors can do fast and what they can't do fast. We can find how avoid slow things if you want your code to run fast. Background for other more in-depth classes. There is just so much you can do with standard processors. You may need to design our custom hardware for extra performance. You can find this is a difficult task for our country. So you can find in Intel company. They can design and product CPU, but in China we can't product our own CPU. We have used the CPU from Intel, from AMD, but we can design, we can redesign, we can divide and merge. Yeah. Okay, let's have a rest. Because this is the number 8 week. In this semester. So after 2 weeks, you can find this semester is overpassed. Yeah. So time is fast. Time is fast.
Yes.
Okay. We can find the hardware of a processor, such as RISC-V processor is an example of a synchronous digital system. Synchronous is all operations coordinated by a central clock. So you can find one word. This is heartbeat. Heartbeat is the signal of the system. So you can find processor frequency is heartbeat. Heartbeat is boom, boom, boom. Yeah. So it's very useful for the computer. The signal of computer, the input signal is the heartbeat signal. So you can find in several courses, heartbeat is the more useful and useful. You can find in some courses. Digital is the useful for computers. The computer is digital. Yeah, you can find the digital can represent all values with 2 discrete values. The 2 values is 0 and 1. So binary code is useful for computer. It is repeat and repeat to learn. Yeah. Electrical signals are treated as 1 and 0. 1 and 0 are complements of each other. So binary code is from this electric signals. High and low voltage. Voltage is the electrical signals, one of electrical signals. We can find the high voltage and low voltage can represent 1 and 0, true and false. You can find the high voltage, low voltage. He is very disparate. Yeah, you can find high voltage is in this, low voltage in this. So you can divide
up and down.
Yeah. Switch and transistors. We can find a switch. Switch is useful open and closed tools. You can find the basic element of physical implementations. We can find in the wall. This is the switches. The switch is the basic element of physical implementations. You can find if input is 1, the switch is averted. So you can find 2 operations, open and close. Open switch is A is 0 and turn off light bulb. So you can find that this is
A0.
This is closed.
Yeah.
This is open. you can find the closed switch if A is 0 and 10 on light bulb. So you can find that this is the light bulb. Switch logic, we can find this image is high level than this image. Or we can find the logic. The logic is very interesting. Can compose switch into more complex ones. We can find that this is Boolean functions. Boolean is very useful in computer organization. Arrows show action upon assertion. So you can find the AND and OR is two important logical operations. This is the input and another input. This is input and another input. This is the AND operation. This is the OR operation. So you can find that this is the switch logic. This is link together. This is link divide. So you can find this is AND, this is OR. AND and OR operation is very useful. Historical note, we can find early computer designers built ad hoc circuits from switches. So the ENIAC in 1946. The earlier computer isn't useful, isn't powerful. We can begin to notice common patterns in their work. AND and OR. AND and OR is early logical operations in computers. So you can find in early computer we can compute it by add, sub, multiple and divide isn't useful. We can find that add and sub is earlier operation in computer, but multiple and divide is computed by add and left and right, left rotation and right rotation. So you can find the master thesis by this man in 1940 made a link between work and 19th century mathematical George Boole. Call it, this is the important term, Boolean. In Chinese we call Boolean. Boolean in Chinese, in English, in Chinese, Boolean. Yeah. Boolean is very useful. Could apply math to give theory to hardware design. Minimization is useful and important products in current. Computers need switches. We can find to create an electric computer. We need the ability to control switch with electricity. The electricity is the necessary power in computer. So we can find switches controlling groups of other switches. So electricity should flow through the switch. So we can find the switch, and the switch is the necessary operation. Transistors are hardware switches. We can find modern digital systems designed in CMOS. MOS is metal oxide on semiconductor. C for complementary, normally open and normally closed switches. MOS transistors act as voltage control switches. Okay, we can find the transistors and the CS61C. The internals of transistors are important, but won't be covered in this class. Physical limitations relating to speed and power consumption can take some symbols. We will proceed with the abstraction of digital logic. It's also important to understand hardware trends. The trend is very, very important. We can find the iPhone 12 can represent the trends, but the Huawei company, the mobile cell phone, the newest mobile cell phone is the trend for China. So we can find the more and more famous company is our advice for the customers. As the customers, we like to more and more chooses. So in China, iPhone 12 is hot. Customer for recently. Yeah, my classmates, my students, my college had buy iPhone 12 in recent.
Already buy that.
But the custom is we can buy in website in buyers, but the iPhone 12 has shortcomings.
Yeah.
You can find the voltage. You can find the limitation of 电池
battery.
Battery, yeah. The battery, the size of battery in iPhone 12 is small.
Yeah.
In Huawei cell phone, you can find the size of battery is big. So the size of battery is according to the use time of use time. Yeah. So you can find the trends is different. You can find this is 1947. This is the 1947. The structure of 1947, and we can find from the left to the right. You can find the size is small and small. In current, we can find nami. In Chinese, nami. Yeah. This is meter. Yeah. You can find in 2019. We can find the processor technology archived 7 nami. Yeah. This is not the limitation. They can small and small.
Yeah.
7, yeah.
How do we see this? Can we see this?
This is silicon anode. Yeah. This is the Moore's law. Moore's law is very famous. Moore's law. The number of transistors on integrated circuit chips. We can find this is the trend. This is the trend. After years, we can find from 1970 to now. We can find the trend is big and big, quick and quick, and the price is lower and lower. Yeah, you can find the CMOS. We can find the N channel and the P channel. This is the content from digital circuits. Yeah, you can find the N channel and the P channel. 3 terminals, source, gate, and the ring. Switch action is voltage. 1 gate terminal is some amount higher, lower than source terminal. Then conducting path is established between drain and source terminals. You can learn. Most networks, you can find the voltage source. This is 1, this is 0. The 0 is represented 0 or ground. The ground is 0. So you can find what relation between X and Y, 0 and 1. Two input networks, and you can find that this is the result of two input networks. You can learn. Abstraction, we can find black diagrams. Diagram is very useful and powerful. In reality, chips composed of just transistors and wires. Small groups of transistors form useful building blocks, which we show as blocks. We can combine to build higher level blocks. You can build AND, OR, and NOT out of length. The three option operation is logical operations. Okay, we can find the combinational logic. The combinational logic had four sections. One is combinational logic gates, two is truth tables, three is Boolean algebra, three and four is circuit simplification. Okay, we can find digital system consists of two basic types of circuits. One is combinational logic. Output is a function of the inputs only, not the history of its execution. For example, circuits to the operation add is operating code. Sequential logical. We can find the circuits that remember or store information. You can find the state elements, for example, memory and registers. So you can find in CPU, registers is very useful and powerful, but the number of registers is small. We hope the number of registers become more and more. So this is the four logical operations. You can find the NOT, AND, and OR. This is the symbol of NOT, AND, and OR. This is the result of input and output. In Chinese, we call this 真值表. In English, you can find this is the true value table. In Chinese, we call 真值表. 真值表. Yeah. In English, we call this true value table. Yeah. In this table, if you get the table, you can find the input and output results. This is logical gates. You can find that this is different. This is different from the last page. You can find NAND, NOR, and XOR. XOR is another logical operation. You can find in this true level table. You can find if the input is same, the result is 0. If the input is different, the result is 1. So you can find the XOR is another operation. So if we get the true value table, the result we can get. Okay, this is an example. Or we can find combined multiple logic gates. You can find 1, 2, 3, 4, 5. This is two. They have five sections in one logic gate. You can find that this is the representation from this page, this image. You can find A, B, C is 3 input, D is the output. So you can find in this equation, you can't find the B. You can find A, B, C. You can represent this D equal this equals this formula. So you can find in this red format, we can find A is A, B is B, from A, B, we can find that this is input, this is output. The output is A and B. So A and B, you can find according to this operation, this is not. So you can find according to this, we can find the result is not A and B. We can find this A and this is according to not operation, this is not B. This is C. Not P and C. According to this operation, we can find this is AND operation, not B and C. This is the result of this point. A and not B and C is the two important input. You can find the output is this. You can find this and this is the two important from in this operation. This is the AND operation. You can find this is the form. So this is simple. If you have complex circuits and combining, you can find the logic gates can become more and more. So if you like, you can find some circuit gates, logic gates in every signal. Okay, this is an example. Okay, truth table, we can find the representations of combination logical text description, circuit diagram, truth table. So we call true value table. They call truth table. Here is same. They are same. They have Boolean expression. OR. This is important. All are equivalent. Yeah, truth table that relates and inputs to a combinational logic circuit to its output. Output only depends on current input. Use abstraction of 0 and 1 instead of high and low voltage. Shows output for every possible combination of inputs. You can find 0 and 1, 0 or 1 for each of n inputs. So the n is equal. So you can find 2 equal n rows. So this is an example. General form. If we have 3 inputs, so we have 8 outputs. 8 is 2 equals 3. So you can find 3 input can represent 2 equals 3 output. So we can find this, the number of this, the ABC is 8. So if n input, how many distant functions f do we have? Function maps each row to 0 or 1. So 2 equal r possible functions. Okay. Multiple outputs. This is a simple or general form. This is multiple outputs. From the left, you can find the ABCD is 4 inputs. From the right, you can find XYZ is 3 outputs. For 3 outputs, just 3 independent functions. We can find XYZ. XYZ is the 3 outputs. In X, in Y, and in Z, ABCD is the 4 inputs. For X, for Y, for Z. You can show functions in separate columns without adding any rows. So this is the multiple outputs. Okay, this is the question. Convert the following steps into a truth table. You can find a formula. In this, we can find XYZ is 3 inputs. ABCD is 4 outputs. you can find a truth table for x, XOR y. The result OR not Z. So we can find if x, y, z in this formula, A, B, C, D can represent. The question is, convert the following statements into a truth table form. You can find the B column. The B column is the result. Okay, more complicated truth tables. We can find A, B, C, and Y. This is 3 input majority. This is 2-bit adder. This is how many rows is the problem. So we can find A, B, C. We can find A1 and A0 is from A. B1 and B0 from B. C0, C1 and C2 from C. So we can find A and B is 2 inputs. C is output. So this is the problem. How many rules? We can find A has 4. A has 4 input, 4 different. B has 4 different. So 4 different and 4 different combined to combination, we can find the 8 different rules. We can find this is not necessary. This is the necessary. So we can find the row. The row is 8. Okay. Today is enough. We have continue in Thursday. This week is number 8 week. In next week
we have lab class, experiment class in the science building.
Yeah, in Thursday. In Thursday. This is 8 o'clock. This 8th week. In next week,
morning.
In this schedule, we can find we had
experiment.
But experiment laboratory isn't in this.
In science building.
Yeah, in our college.
Yeah.
In the column. Yeah. So you have our WeChat. If you can't find the laboratory, you can contact me. I'm waiting for you in laboratory.
Okay.
Yeah. Okay. You can remind. You can remind.